It could be, I don't know, maybe, look, as I said, there is a possibility that, when you try to rewrite your differential equation such that it will be in the phase variable canonical form. In that case, you can, without writing this operator this way, you could have the transformation. Okay, but anyway, try to do whatever you can, and I will, let me see what can I do. Okay, this is the concept for it. But as I said, we did not cover it. Unfortunately, we did not cover it. This is, this is, they call it the controllability. They call it controllability matrix, but we did not take it. Okay, let me go back to our lecture in here. In our lecture in here, what we said, we would like to study the stability of the system. We said unstable systems are not quite useful. So if you have any unstable system, try to stabilize it. We will be, talking about the definition of stability, and then how do we test whether the system is stable or unstable. In this lecture, we try to, test the stability of the system from the Routh-Hurwitz criterion. We will be talking about also the concept of relative stability, and I'll try to define it a little bit later. So today we will be talking about defining what's the stability, what is how do we find the system is stable or unstable. Okay, one method of it, which is, the Routh-Hurwitz. Later on, we will be talking about the root locus. We will be talking about Nyquist. So there are many ways of testing whether the system is stable or unstable. We will start with the Nyquist, but before Routh-Hurwitz. But before that, what is stable system? Suppose I have a system, and this is, let's say, R of t is the input. This is Y of t is the output. What is a stable system? The stability in this course, we are going to define in a certain way. One way, one format of stability. Any suggestion, any idea?
Yes, Doctor.
Okay. Yes.
Because the balls, the real part should be in the left half plane. This is the rigorous definition.
No, this is not definition. This is a test.
Or a test, yes.
This is a test.
Doctor.
The definition.
Yes, Doctor. Bounded input, the output should be bounded.
Great. Bounded inputs, a stable system is defined with a bounded input response to a bounded output. That basically, suppose I have a step in here, step input, and my output like this. Is this system stable or unstable?
Should be stable.
Should be stable, because I can put a bound in here.
Let's call it Bibo stable.
Exactly. So basically, if the response will be like this, so it's become unstable. Of course, the definition of stability is, there are many ways of defining stability. For example, if you go to nonlinear system, you will have certain type, the definition of stability. If you are talking about, state space representation, you have another definition. But at least in this course, we will be talking about bounded input, bounded output stability. Well, so if you have a bounded input, bounded output, or an initial condition, then the response will be, if it will be decreasing, then the system is stable. If it will, just oscillate, we call it neutral, or, marginal stable system, or it will be increasing. The test for it is the poles of the system must be in the left half plane. If the pole in the left half plane, then my system is stable. This is, we test, but the definition is it's bounded input, bounded output criteria. Any question? Well, think about, I think last time we talked about this example. If you have small perturbation in here, well, this, okay, shape will, maybe it will move a little bit, but it will come back to its position. So this is a stable position for the system, while this is unstable, because any small perturbation, it will take the system from this position.
What do you mean, Doctor, by in small perturbation?
Well, suppose, okay, you are driving from here to Riyadh, and your car is a small car. Okay. If a giant car come beside you, okay, what do you feel?
Wallah, it depends on the size of the car. If it's a truck,
no, that's what I'm saying. Take a small car, very small car.
and you don't feel anything.
You don't feel anything?
Let's take a truck, Doctor.
لا بالعكس, practical. You don't feel anything?
And for me, it depends on the speed of the car.
I'm telling you, no, let depend. I'm telling you, small car. I'm giving you the condition. It is very strange you don't feel anything.
والله دكتور اسالني على
unless انت تمشي على سرعة 10 كيلومتر بالساعة.
او اللي جنبي يمشي على 200 اكيد.
That's what I'm saying. Look, a small perturbation, يعني, okay, let me put it maybe another example. Suppose you have a ball in here and you kick the ball, but your kick is not very strong. What will happen?
Well, the ball will move a little bit, then comes to its place.
Exactly. That's what I'm saying. This is the situation. Or this situation, maybe. But if you are ball in here and you give the same kick you gave in here, what will happen? What will happen to the ball?
Just a very small kick will make it to the Mars.
Well, apply the same thing in here, okay? In here. You said in here it will come back. What will happen in here?
Yeah. So this is the center of mass, Doctor.
Yes?
This is the center of mass.
It will. Basically, it doesn't stay in its place.
Because the center of mass is, is not located. Yeah.
لا تعقدها أكثر مما ينبغي. It is, take a ball in this position. If you just kick it, because the situation, this is this is a pendulum. Let's think about it, a pendulum, and you are putting this pendulum. If you just give any disturbance, any little bit of air will come, it will, it will not stay in its place. Okay. So basically, this is what we are talking about. This is what we mean if the system is stable or unstable. Okay, you can think about it. Okay, this is a motion. Unstable could be a heat. Okay, uncontrollable heat. Okay, what happened?
كيف يا دكتور?
What happened in Chernobyl? Okay, they could not control the heat, so it became unbounded, and then it will burn.
ايش يا دكتور؟ ايش الصاروخ هذا اللي اطلقوه ولا ايش؟
لا مش الصاروخ. تشيرنوبل كان في رياكتور مكان they produce electricity. Okay.
Yes.
A nuclear reactor. All of a sudden they couldn't control the temperature in there.
انفجار صار طبعا.
Right. So that's what I'm saying. This is stability. Okay. Now. Well, stability, okay, suppose I have also the transfer function of various systems. This is the first transfer function, this is the second, and this is the third. We can visualize stability in the time domain clearly. Suppose I would like to get the impulse response. What will be the impulse response for the first one?
It's e to the power of minus t.
Exactly. How about the next?
It's a step function.
It's going to be constant, isn't it?
Yes.
And so if the system is stable, this is the behavior. If neutral stay as is, if it's unstable, then the response become unbounded. And this is in the time domain. You can visualize in time domain, you can see where are you heading. Okay, but it is very difficult if you have complicated system to go to the time domain and visualize. So usually we would like to have a test for the system in the S domain. As I said, this
Well, usually, doctor, it's hard to find the transfer function.
okay.
Usually, it's hard to find the transfer function.
But suppose you have a differential equation. No, look, you have a differential equation. What I'm saying, you have, suppose, let's say, d to the 10, okay, d to the 10, dt 10 plus 65 d to the 9, y dt 9, and so on. That's equal to 66 u. Okay. How do you solve this? How do you solve this differential equation?
You solve it by Laplace.
But it's very difficult to get the transfer function.
Yeah, sometimes it's difficult, yes.
So this is easy. Transfer function is easy.
Yeah, for this example, بس دكتور لما يكون عندك non linear.
عبد الرحمن انت لا تعقد الامور اكثر ما هي تحتمل. ابدا بالشيء المتواضع وبعدين build on الcomplication, build it on.
تمام.
Don't put, assumption which will maybe it's valid. What you are saying is valid. لكن in general, we are talking. So far, what did we take? What's physical system which we take? Circuit, op-amp, DC motor, mechanical system, which is spring. All of those are simple, and they can have transfer function.
Just, doctor, we want to shed light on the real life.
In real life, yeah, definitely. Well, in real life, no system is linear. Almost all the systems are non-linear. Okay. For example, take the. Did you take 360?
360, yes.
Okay. Now, what will be if you take the DC motor, okay, and you are running experiments? What will be the resistance of the coil at the beginning of the experiment and after, when you finish the experiment?
The resistance of the coil?
Yes.
Yeah, it will be non-linear at the very beginning, and then.
What did you do? I mean, when you study the course, what did you do?
We linearize,
You neglect the effect. So okay.
Yeah, because it's a very small, there are certain assumptions.
Look, I mean, definitely what we are doing in here, we are assuming, yes, because, once you understand the concept, you go to the nonlinear course. As I told you, in the stability, we don't use this definition. They use the Lyapunov definition. But the important thing, in order to build a building, you have to put the roots. You have to understand the basic and then go. Okay? So, suppose so basically we would like to go, okay, and, do the analysis based on since in this course, it's a linear course, and we are going to talk about, transfer function. So we will put the test based on the transfer function. Now, definition of absolute stability, basically, is the system stable or unstable? Simply, either my system is stable or unstable. Suppose I have a system in here and I have 2 poles in this place. Is the system stable or unstable?
Stable.
Okay. What about the system in here?
This is stable. Also.
Stable also.
Stable. However, the degree of stability, if you want to put a degree, which one is better, this one or this one?
The
first
farther
one.
side is better.
The farther, the far away from the j omega x. So the relative stability, it will take a definition, it will take, this concept. In Routh-Hurwitz, we will, define the relative stability, but later on, we will have better measure of the relative stability. Okay. Now, suppose I have this system. What will be the transfer function of the system?
G of S over 1 plus G of S H of S.
Okay, y of s over r of s, which is equal to g of s over 1 plus g of h of s. So in order to test the stability, I will look into the pole of the denominator, isn't it?
صحيح.
Okay. Well, let me call the denominator the characteristic equation. So delta of s equal 1 plus the loop gain. So finding the roots in here is the same as finding the roots of the pole of the system. And that's basically what we are going to deal with. Okay? Well, basically, to test if the system is stable or unstable, you find the roots of the characteristic equation, as I said. And that will tell you if they are in the left half plane, the system is stable, otherwise the system is unstable. What we are going to do in Routh-Hurwitz, in Boot-Lucas, in Nyquist, we will give certain conditions and certain conclusion from the characteristic equation without finding the exact roots. We don't find the roots. We can answer whether the system is stable or unstable based on the characteristic equation without solving the characteristic equation. Okay? So let's go to the Routh-Hurwitz criterion. We will start the first test for stability. We call it the Routh-Hurwitz criterion. The Routh-Hurwitz criterion will answer the question, is the system stable or unstable, without, as I said, solving the characteristic equation. Okay? Well, before we do that, let's look into a second order system. Suppose I have a second order system. This is a polynomial. So how many roots I will have? How many roots?
2.
2. So suppose I factorize my roots in this way. And let me multiply the roots again, reconstruct the polynomial again. So I will have a square minus the summation of the 2, P1 and P2, plus the multiplication of the 2. Okay? The first observation, what are the coefficients of the polynomial? What are the coefficients of the polynomial?
The coefficient of S is the summation of the roots, and the coefficient of the constant is the multiplication of the roots.
No, in here, what I'm saying, what are the coefficients in here?
A1, A0.
1, A1, and A0. Now, for the roots to be in the left side, all the sign in here must be the same. For example, I have two roots. Suppose P1 is positive, but P2 is negative. So one in the left half plane, the other in the right half plane. Okay. What will be the sign in here?
Be negative.
It's going to be negative in here. Okay. If both of them negative, if both negative, what do we have in here? If both negative, this will be positive, and this will be positive as well. So basically, the observation is that for this polynomial, okay, or for the system, not to have the roots in the left half plane, in the right half plane, all the coefficient here must have the same sign, either positive or negative. It's an equation, so if they are negative, multiply everything by -1, it will be positive. There will be no sign change. Okay, if there is no sign change, okay, or at least it is necessary that there shouldn't be a sign change for the poles to be in the left half plane. If there is one sign change, then definitely you will have one of the poles is going to be in the right half plane.
بس يا دكتور
Yes.
لو كانوا البوث بوزيتيف
Okay, both positive. عندك
يكون عندنا
negative.
الترم راح يكون عندنا الترم اللي في النص نيجاتيف والبقيه بوزيتيف.
بالضبط.
طيب مو المفروض يكونوا كلهم سيم ساين؟
كيف؟
مو المفروض كلهم يكونون سيم ساين؟
يعني الobservation او الfinding is that okay, if there is a sign change in here, if there is a sign change, one of those is going to be in the right half plane. It doesn't mean that if there is no sign change, they will be in the left half plane. No, what says if there is a sign change in here, for sure one of the pole will be in the right half plane. But if all of them positive, it doesn't mean that those are going to be in the left half plane. So
ليش يا دكتور؟
كيف؟
عشان الزيرو يعني ولا ايش؟
كيف؟
عشان الزيرو.
إذا كان if one of them is missing, if one of the elements is missing, okay, again, one of the pole of the second order system is going to be in the left half plane, in the right half plane.
لا قصدي مش missing، يعني لو كلهم positive, they should all be in the left half plane, as simple as that.
No, we will see.
Counter example.
Basically, I will come to you if you just give me a couple of minutes. Okay, this is in general. This is the nth order system. Okay, this is the nth order system. Okay, basically, if you factorize it, those are the roots. Reconstruct them, so you will have an Sn minus an, the summation of the roots, plus an, the multiplication 2 at a time, then minus you take 3 at a time, and so on. The condition is that, suppose I have, let's say, s cubed, okay, minus 2s squared plus 3s plus 1 equal to 0. I can immediately say my system is unstable. Find the roots of this equation. If you find the roots, you will have one in the, at least one, no, two in this case. I have two sign change. because this is positive, negative, positive. Two of the roots are in the right half plane. Or s cubed plus 3s plus 1 equal to 0. This is also unstable because the coefficient in here is missing. So, Routh-Hurwitz, this is a necessary condition. All the coefficients must be of the same sign. This is necessary, but not sufficient. Meaning, anybody from the high school, who finished high school, okay, and he took all the needed exam to prepare his file to go to KFUPM, he must finish high school. He must take the exams. But does that guarantee him a seat at KFUPM?
No.
No. So it's a necessary condition. If you don't have high school, you cannot apply. But if you apply, they may take you or may not take you. Okay. Well, okay. For the roots to be in the left half plane, all the coefficients must have the same sign. The counter example. Suppose, okay, suppose all the roots, all the coefficients are positive and there is nothing is missing. Take this one. Can I say my system is stable or unstable?
طبعا انا دكتور كلامي على السكند اوردر مش على الثيرد اوردر.
Second order. Okay, let's take.
If second order
is easier, yeah. Okay. Second order. What you are.
تدري ليش يا دكتور كلامي على السكند اوردر؟ لانه في الثيرد اوردر يصير عندي 3 I will add مثلا مع الاس سكوير 3 roots. تمام؟ if 3 of them is negative and then I will multiply by negative so it will be positive, but there when you multiply two consecutive roots it might change the sign. فقصدي انه يعني ما هو شرط في الثيرد اوردر.
No, look, I'm not sure, but there is, okay. Basically, in the second order, s square plus, let's say, this is a b s plus c equal to 0. The s equal to what? Minus b, isn't it? Plus or minus roots of, okay, b square minus 4ac, okay?
Over 2a.
Huh?
Over 2a.
Over 2. But forget, the 2 will be fine. But what you are saying?
2a ولا
2a? Okay. But okay, look at the numerator. What you are telling me, okay, minus b, let's say, take the other plus root of b square minus 4ac. This is always positive?
دكتور الحين if I what I'm saying if a and b and c.
Wait. No, Abdurrahman, wait. This is what, this is general second order system, isn't
طيب.
it?
ممتاز.
Solution. So what you are telling me, check for me this equation, not necessarily now. Okay, what you are saying, okay, this is always, okay, this is always either positive or negative.
لا مش هذا اللي اقوله انا. اللي اقوله يا دكتور انه لما يكون ال A وال B وال C positive it will be stable. The system will be stable. Sufficient condition.
No. Check this one. Okay, tell me. Okay. الحين let's take example. take B equal to 1.
ممتاز.
Okay, okay, let's take, okay, I don't want to, okay, I want it to be, let's take, okay, B equal to 2 for AC, B, because if, okay, so B must be greater than this one. Okay. Minus what we want, the condition, I want, okay, look, what I want, is it possible to find B squared minus 4 AC is greater than B? Is that possible? Or not? Possible?
والله
No,
لازم
not
نحل ونشوف.
Anyway.
Not
Yeah.
possible.
كيف؟ I'll try to see.
لحظة يا دكتور، لو كانت لو كان واحد
look I think let's okay.
I think it's possible، بس خليني اقول لك ليش. طيب لانه انت سألت سؤال.
عبد الرحمن I don't have time يعني الحقيقة تعرف I have to cover material.
خلاص ما في مشكلة، بس انت سألت سؤال عشان كذا كنت بجاوب بس.
لا بعد اوكي after 12 اوكي
تمام.
لكنه قلت لك لان تعرف I have to cover certain material. In general, look, this is a theorem. I'm sure there is something. I will try to come next time. I'll double check the second order. But in here, look at this one. This is what you will get. The system is unstable. This is, you know, when they put a theorem, they put theorem in general, not for specific thing. So what we are saying in here, Raoult-Perouse criterion is a necessary and sufficient criterion. What we are going to do next, okay, what we are going to do next is give a procedure, okay, how to make sure that the system is stable from the characteristic equation. We know that if one of the terms is missing or negative, then immediately we abort, and then for sure the system is unstable. The question is, if all of them they have the same sign, is the system is going to be stable or unstable? This is basically the okay, the sufficient part. Yes, the sufficient part will come. Now, suppose I have this system again. Let me write the characteristic equation. Okay, what is the characteristic equation here? The delta of S equal to 1 plus G of S, H of S. And this is going to be polynomial. Okay, suppose my polynomial is going to be equal to a n s to the n plus a n minus 1 s to the n minus 1 plus a n minus 2 s to the n minus 2 until a, let's say 1 s plus a naught. This is equal to 0. This is the characteristic equation. The Raoult-Perouse criterion, okay, the Raoult-Perouse criterion came in, you know, making a matrix. This is s to the n minus 1 minus 2 until s1, where the first row, the first two rows of the matrix will be taken from the polynomial. That's basically, this is the polynomial. The coefficient of Sn is going to be an, then I skip one, go to the next, and then skip. So you can say the even number or whatever. You take the first, now maybe you have you know, third order, so it's not necessarily even. So you start with first an, then you skip one, skip another one. The one which you skip in the first step, you put them in here. So this is, you know, given to you. Okay, you form this, the first two row of the matrix. What we want to do next, we would like to make the following matrix. This is the matrix which we want to make. The blue one is already given to you. I would like to calculate the third row. The algorithm is that Bn minus 1 equal to minus 1 over B, A and minus 1, this one, multiplied by the determinant above it, an minus 1, an minus 2, and an minus 3. Okay, so this is basically what we have. This is the way we calculate Bn minus 1. Bn minus 1, you take it, the coefficient here, minus 1 over the coefficient just above it, multiplied by the determinant. Okay. Then, once I am done with this one, let me get Bn minus 3. Bn minus 3 then equal to, again, minus 1 over, I will take again the same element, the first element, an minus 1, and the determinant, I keep the same column, and I skip this column. I will go to the next one. So it's going to be an minus 4 and an minus 5. And I will continue. So this is Bn minus 3. What do you think Bn minus 5 will be?
ناخذ أول كولن مع الكولن الرابع.
Exactly. So minus 1 over an.
Systematic يعني دكتور.
And an minus 1. And then it's going to be, this is B5, so it's going to be an minus 6 and an
minus 7.
Minus 7, an minus 7. Until you will, continue in that format. Once you build this one, so we build the third one based on the first two. What do you think Cn will be? Cn minus 1.
والله كجس ممكن نسوي مع البي ان نفس الكلام.
It will be exactly Cn minus 1 equal to minus 1 over Bn minus 1 and those two rows. An minus 1, Bn minus 1, okay, and an minus 3, Bn minus 3.
And this doctor can be programmed.
Yes, you can, definitely. So look.
Doctor?
Yes.
What do these value represent? Bn and An, Cn.
Okay.
These values, what do they mean? An and Bn and Cn.
Okay, we will come to the theorem where we will be using them. First of all, this is the way the construction. Do you have any problem in the construction?
No, it's clear.
Okay.
Doctor?
And to دائما ahead, which is great. Okay, so basically we form this matrix. Okay, until the last one. Well, we will count in here in this first column how many sign change. The number of sign change mean the number of the poles that are in the right half plane. And then clearly, if I know how many poles in the right half plane, then I know whether the system is stable or unstable. So I will use the information, and this is a theorem or by Rawth Hurwitz. Basically, Rawth was working mathematician and Hurwitz another mathematician. They joined Therefore, and this is basically what we have. The Routh-Ruse criterion state that the number of roots of Q of S with a positive real part is equal to the number of changes in the sign in the first column of the array. This is pattern. Plus minus is counted as two sign change. So for the system to be, okay, for the system to be stable, there shouldn't be any sign change. I hope this answered the question which one of you asked. What do we do with it? This is basically test.
هذه دكتور sufficient conditions ها؟
Well, this is necessary and sufficient, both.
يعني this can ensure stability of the system.
Exactly.
يعني if there is no sign change, the system is stable.
Exactly. Now, however, what we are going to, it's not that simple. We are going to see 4 possible cases. The first case, all the elements in here are non-zero. All the elements in the first column are non-zero. Now, suppose this is 0. Okay. Suppose this is 0, but the other are not 0 in that particular. Can I proceed?
No, you cannot.
You cannot, because you cannot divide by bn. We will deal with it. We will assume in here I will have an epsilon and I will deal with it. So this is another case. This is simple as this is one case. The other case is that this is the entire row is zeros. Again.
أي row معلش يا دكتور؟
كيف؟
Which row?
Let's say any row before the last one, before S to the n. Before.
جميل.
Okay. So if this is the case, it means that, somehow my system, it has poles on the j omega axis. We will show it. And we will deal with it. A fourth.
يعني هذه special cases دكتور.
مش special cases. لا هو يعني you will deal with all possibilities. يعني life is not simple. No, immediately, okay, there is no sign change and that's it. No, I mean, the theory, it has a lot of, the test is not that very simple, not straightforward. The last case, I will have 2 repeated, you will have this one and another one also will be 0. Okay, so which means in a way I will have double pole at the j omega axis. We will be dealing with all of those cases. Okay, the simplest, I think now it is about. Okay, let me do this quickly. Suppose this is the example which I have. This is G. Okay, let me put the characteristic equation. So this is G of S. What is the characteristic equation? Tell me. Can somebody tell me? Delta of S equal to what? 1 plus G of S, which is going to be S cubed plus S squared plus 2S plus 24 equal to 0. Do you agree?
23.
23.
لا 24 صح جمع الواحد مباشرة.
هنا. So S cubed, S squared, S to the 1, S to the 0. Now in here I will have 1, 2, 0. The other one I will have 1, 24, and 0. Isn't it?
بس دكتور الحين G of S is 1 over. كيف جمعتها مع واحد؟ كذا.
Yes, he's right, Doctor. How is delta S equal 1 plus GS?
Clear the fraction شباب. الله يرضى.
أوه.
الله يرضى عليكم. Clear the fraction. Okay.
قررت أزود السرعة شوي. تمام.
طيب. إيه لأنه المشكلة الوقت and I have to. Okay. Now let's calculate in here. S1. What's the coefficient in here? The coefficients go
2, 0.
Will be minus 22.
Exactly. How about here? At this stage.
هذا will be 0.
How about here?
Zeros.
No, 24.
لحظة دكتور. أو لا أنا أتكلم حسبتك تتكلم على اليمين.
this is 0. Multiply those and divide
صح.
minus 22.
واللي بعده على اليمين 0 بعد. Third column.
Yeah. So this is basically what we have. How many sign change I have?
I have 2 sign changes.
Which means that I have 2 roots of the system in the left, in the right half plane, which means my system is unstable. Okay.
سؤال يا دكتور.
تفضل.
الحين احنا اعتبرناه يونت فيدباك صح؟
حتى لو مو يونت فيدباك فاين.
لانه احنا حسبنا دلتا اوف اس 1 بلس جي اوف اس.
This is in this case unit feedback.
Yeah. So just to make sure يعني.
Yeah, this is unit feedback. What you'll have, the characteristic equation equal to 1 plus g of s, h of s. So in this case, h of s equal to 1. Fine. Easy.
تمام.
Okay. Any other question?